Hello guys, so back again. We're gonna go ahead and get started with lesson 4. Again, we are not gonna be able to go over this stuff during class because we are behind and you guys have a test next week. So please make sure that you're watching these videos, taking notes. If you don't have your book, take notes on a separate sheet of paper. At least have some idea of what's going on, because if you don't watch these videos, you're gonna be completely lost on next time I see you. Okay. So we're only gonna do half of this lesson. I'm gonna make sure I go over the other half during class, and then yeah, maybe we'll do the test review as well. So we'll see how much time we have. So let's go ahead and get started. So this one is gonna be on page 693. We're still taught. Well, for the last lesson, it was about vertical transformations and all of that. This lesson is going to be more focused on horizontal dilations of quadratic functions. So let's go ahead and get started. Number 1 says consider the three quadratic functions where f of x equals x squared is the basic function. What that basically means is that that's your original. So let's go ahead and go to Desmos test mode, and it should be this one. I already graphed it. It always starts at the origin. That's how you know that that's your original. And then t of x equals 3x squared. So let's go ahead and graph that one. So we're going to go here. T of x equals 3x. I did not graph that right. Okay. Parentheses 3x squared. There you go. So what happened to the graph? It became thinner, right? So whenever it becomes thinner horizontally, this is called a horizontal compression. Please do not get this confused with a vertical stretch. Okay, so this is going to be anytime you see anything inside of the parentheses, anything inside of the parentheses is going to be horizontal. So that's how you know that this is going to be a horizontal compression, because it is inside the parentheses. So this is going to be horizontal. And let's go ahead and graph it. So this was our original, right? This was f of x. And the one that we just did right now was thinner, like this. This is t of x. And let's put that right here, horizontal compression. And what do you think is going to happen whenever, so this one is whenever the number is greater than 1. So number greater than 1 is a horizontal compression. So a horizontal stretch, horizontal, you misspelled that, my bad. Horizontal stretch is going to be whenever the number is less than 0 or a fraction slash decimal. So anytime you see a fraction or a decimal, that means that the number is less than 0, and that's going to be a horizontal stretch whenever it's inside of the parentheses. So horizontal stretch is whenever it actually becomes wider. So right here we have q of x equals 1 over 3. Oh, I forgot my parentheses. 1 over 3 x squared x. And then you can see how much wider that got, right? So this was the original, and this is the horizontal stretch, and you can see that it's getting wider. Okay, so it's similar to the vertical compression, but don't get it confused, okay? You have to remember that anything that's inside of a parentheses is horizontal, and whenever the number is a fraction, is going to be a horizontal stretch. So let's do purple for this one. And this one was way wider out here, and this was q of x. Okay. How are you going to write this? Well, for t of x, That's going to be f of 3x. That's how you write it as a function. And for q of x is going to be f of 1 over 3x. That's how you write that. Okay? All right, moving on. So use coordinate notation to represent the dilation of each function. Each point xy on the graph of f of x becomes the point. So for the first one, it was 3x comma y. So the y value doesn't change, but whatever your x value has to get multiplied by whatever number was in the very beginning. Okay, so for us it was 3. Same thing here, but this one is going to be 1 over 3x comma y. So we're multiplying every x value by 1 over 3, and the y stays the same. All right, this is really important to highlight. A horizontal stretch is the stretching of a graph away from the y-axis. Horizontal compression is the squeezing of a graph toward the y-axis. Okay, so right here, 1 over 4, that is a fraction. Remember, whenever we have a fraction, we said that that was a what? Horizontal what? Let's go up here. If a number was a fraction, we said it was a horizontal stretch. So this right here is going to be a horizontal stretch by a scale factor of 1 over 4. The scale factor simply just means what is the number that we're multiplying by? What was the number at the beginning? So right here, that was the number at the beginning. So every x value is going to get multiplied by 1 over 4. And then in the bottom, this was a number that was greater than 1. So this is a horizontal compression. This is whenever the graph gets thinner, right? And this is by a scale factor 4. So the graph is going to be really thin, and for this one, the graph is going to be really wide. Okay. All right. Write the function wx and z of x in terms of h of x. So it's going to be wx equals h parentheses 1 over 4x, and then z of x is going to be h parentheses 4 of x, just like that. All right, let's go on to the next one. We're going to go, whoops, we're going to skip a lot here. I'm looking for number 3. Where is it? Did I skip it? Uh-oh. Wait, hold on. I think I might have skipped it. Given f of x. Let me see something real quick. Okay, I think I might have skipped it. Sorry, guys. I'm gonna have to look for it because it's kind of, I'm trying to go based on the videos. And you know how the videos are all scattered, so I have to kind of see where this one was. Is it even this one? Nope. Oh, wait. Okay, got it. Right here. This one. Sorry, you're going to have to go through some pages, but find the page that looks like this. Okay, so we're going to be doing this one in decimals, and I want you to also be pausing the video and you practicing on decimals how to be graphing this, because it's really important that you know how to use decimals. Okay, you don't learn by just watching somebody do it. You have to actually do it yourself and see if you know how to do it. So it says given f of x equals x squared. That's always our original. So right here, I already had it. That's our original. Write each corresponding quadratic equation. So they want us to write these down. Okay, so we're gonna see what we get. What do you think is gonna happen? What do you notice about the equations. Well, I know that this is inside of the parentheses. From lesson 3, you would know that anything inside of the parentheses, you do the opposite, and it moves either left or right. So -2, your brain would tell you, okay, move 2 units to the left. Nope, you do the opposite, which is move to the right 2 units. So we know that this graph is going to be moving to the right 2 units. And then anything anything outside of the parentheses is going to be your vertical transformation. So that's going to tell you, are you going to move up or down? So this one right here, we're going to move up 3 units. And this one we do as our brain says. So up 3, you would think, okay, I'm going to go up 3. Yeah, right? Or sorry, +3, you would think, okay, I'm going to go up 3. Yes, that is correct. You only do the opposite whenever it's inside of the parentheses. And then we have 1/2 on the outside. So we know that if it's on the outside, this is going to be a vertical transformation again. So is it going to get wider or thinner? So let's see. Let's go ahead and graph our original. Our original looks something like this, right, at the origin. And then this one was 1/2 parentheses. Oh, I forgot my F. Parentheses x minus 2. So there it goes, moving to the right 2 units, like we said. And then +3, we said it's going to move up 3. So let's see what happens. +3, zoom out, and look, sure enough, it moved up 3 units. And I'm going to change the color. That way you guys can see these better. I'm going to change it to red. And look, the graph got wider, right? Because this was a vertical, what's it called? Vertical compression. That's whenever it gets wider. So let's go ahead and write that down. The graph went 1, 2, 3, no, 1, 2, and then up 1, 2, 3. So let me change the color actually. So it's going to be right here, and then it got wider. So it's going to be like this and way wider like that. Okay, so then for this one, this was a vertical compression by scale factor of, what was the number? 1/2. Translate 2 units to the right. And 3 units up. Okay? So that's what happened. Now let's do the second one. See if you could do the second one by yourself. So we're going to have our original. So let's go ahead and draw that. We got our original. We already know it's going to look something like this, right? And then let's see if we can figure out, like, if we can predict what's going to happen. +1, outside of the parentheses, this is a vertical stretch. It's going to go up 1, right? +1 inside of the parentheses, that lets me know that it's going to move either left or right. Do the opposite of what your brain tells you. +1, your brain will probably tell you, okay, go to the right 1. So you do the opposite, so it's going to go left 1. -3, first of all, that's a negative number, so the graph is going to be reflected across the x-axis. And then that 3 tells you that is going to be a vertical stretch, okay? And you know that this is a vertical stretch and not a horizontal compression because the number is outside of the parentheses. Remember, anything that is inside of the parentheses is going to be horizontal. Anything on the outside of the parentheses is going to be vertical. So let's see. Let's go ahead and graph it. We have -3, and then f parentheses x plus 1, close parentheses, plus 1 again. You can see that it was a reflection. It moved to the left 1 unit, and it moved 1 unit up. And also it got scaled. skinnier. The graph got thinner, right? Because it was a vertical stretch. So the graph got skinnier. So let's go right here and let's go ahead and graph that. So it went one to the left, up one, and then it got skinnier. So something like this. Something like this, right? So this was a vertical stretch by a scale factor of, what was the number? -3. Of -3. Translate 1 unit left and translate 1 unit up. And that's how you do that. Okay, not too hard, right? Not too bad. Desmos does all of the work. You just have to learn how to analyze. And you could actually graph this without even having to do it at Desmos. We get a lot of practice. You can start just looking at the equation. And remember, anything inside of the parentheses is horizontal, and you do the opposite. And then anything on the outside is vertical, and you do as your brain tells you to do. So that one you don't do the opposite, only whenever it's horizontal and inside the parentheses. Okay. All right. Write n x in terms of d of x when write the quadratic equation for n of x. We're not gonna do this one, so we can go ahead and skip that one. And let's see. Use this must find the vertex and x-intercepts. So let's go down here. I'm gonna have to again. Okay, I found it. This one didn't take too long to find. So go to this page, and we're gonna find the vertex and the x-intercepts. Okay. So what's the vertex? Let's go ahead and graph this in Desmos. So a couple things I want you guys to write down. The vertex is your h comma k, and opposite sign of h is the x value of the vertex. K is the y value of the vertex, and keeps its sign. So think about this kind of like x and y, but start getting familiar with seeing h comma k, because whenever you see vertex like in pre-cal and algebra 2, you're going to see h comma k. You need to know that the h is your x value, but you take the opposite sign, and the k is your y value, but you keep the sign. Okay. And then general form, the general form is just the ax squared plus bx plus c. And then the vertex form, so we're learning new stuff. Vertex form is something new. Vertex form, you have your a, x minus h squared plus k. And then you have your factored form, which is what we went over in class. Factored form, this was whenever you have a, parentheses, x minus, we're going to call it r1, and then x minus r2. Okay. And then last thing that I want you guys to write down is the value of a tells us if the graph goes concave up. So concave up, this would have a minimum. And it goes up when it's a positive number, right? Up if a is greater than 0. or opens down if a is less than 0. And if it opens down, then your curve is at the top, meaning that that is a maximum. Okay, so these are the things that are important for you to know. Now we can go ahead and start filling this stuff out. So I'm gonna let you guys write that down while I look for the page on the book over here where I have it right here. Okay. All right, let's go ahead and get started. If you didn't get that, then go ahead and pause the video or rewind it. For part A, what is the vertex? The vertex, well, we're gonna have to graph this in decimals, okay? So let's go ahead and graph it. So x squared minus 8x plus 12. Okay, let's go to decimals. X squared minus 8x plus 12. So that's what it looks like. What's the vertex? Right here, 4 comma negative 4. So that's the vertex, 4 comma negative 4. Remember, the vertex is, think about like even the word vertex. Look at this. It has a V. That pointy part, that's your vertex. So on your graph, look at the pointiest part of the where it curves. Look at the highest point. Okay, and then a vertex form. This is my H and this is my K, right? So vertex form is going to be X minus, remember I'm looking at vertex form. Let me change the color so y'all could better see it. Vertex form is this one right here. So X minus H, my H is 4. So 8X minus 4, parentheses squared, and then plus K, my K here is negative 4. So I'm going to put negative 4. I don't have to put plus negative 4. Since K is negative 4, it's just negative 4. So that's my vertex form. What are the zeros? The zeros is where it crosses the x-axis, right? So go back right here. Zeros, it crosses right here and right here. So my 0 is when x equals 2 and x equals 6. So right here, a better way to write that is whenever we have 6 comma 0 and 2 comma 0, or when h of 6 equals 0 and h of 2 equals 0. Okay, that's a better, more precise way of putting it. The factored form is just going to be whenever you have x minus 6 and x minus 2. Because you do the opposite of whatever zeros you got. Remember, zeros is the same thing as x-intercepts. So my x-intercept here was 6. What's the opposite of positive 6? Negative 6. Remember, whenever you put anything inside of the parentheses, it becomes the opposite. So that's why it's negative 6. And then right here, it was positive 2. So what's the opposite of that? Negative 2. Okay. All right. And then let's do one more, and I'm going to let you guys, hold on. 1, 2, 3, 4. Wait. No. That's not right. Let me see how much we have left. Let me look at my book over here. 1, 2, 3. Okay, yeah. We're going to stop at this page. We're going to do the rest of it in class, but I'm going to do one more example with you guys, and I want you to do C and D. I'm going to be checking it during class while you're doing your warm-up, okay? So please make sure. I'm going to actually do C because it looks a little bit different than A, and I know you guys are going to get confused. So right here, let's go ahead and put it in decimals. So negative x squared minus 4x. Negative x squared minus 4x. So you can see that because the negative was at the very beginning, this was a parabola facing down, right? Your A was a negative number because that's an invisible 1 in front of the x squared. So since it was a negative number, it was going to be concave down. What's my vertex? The vertex here is going to be at where my max point is, which is negative 2 comma 4. So right here is going to be negative 2 comma 4. This is your H, this is your K, right? So vertex form, again, we wrote it down right here. We're going to have whatever A was. So A here was a -1, right? We could put the 1 or you could just keep it as just negative. Doesn't matter, just know that the 1 is invisible. And then X minus H. What was my H here? My H was -2, so this is X minus -2. Put that in parentheses. And then plus K, plus 4, like this. Another way to write this, you need to simplify this. So this could be written also as negative X plus 2 plus 4. Why? Because a negative and a negative next to each other like this turns into a plus. Okay? The zeros, where does it cross the x-axis? What are the, remember, another word for x-intercept is zeros. All it means, what is zeros? What are the x-intercepts? Look right here, -4 and 0. There you go. So -4, comma 0, and 0, comma 0. Was my factor form? Remember, you have to know what your x-intercepts are to get the factor form, and you do the opposite. So right here, it was -4. What's the opposite of -4? +4, so x plus 4. And then right here, we had, what was it? Which one am I doing? 5B? No, I'm doing, oh my God, I wrote it down on the wrong one. Oh my God, I just realized that. Sorry, guys. Everything that I just wrote down here on part B, write it down for part C. I'm so sorry. I'm so sorry if you already wrote it. Hopefully you caught that, because I know sometimes you guys realize my mistakes before I realize them. So hopefully you realized that I was writing it in the wrong spot before I did. So my factored form, remember, your A, you always have to keep whatever A was. So A here was a -1. Oh my God, I'm still looking at the wrong one. Right here was a -1, right? So you still have to keep that negative. And then it was x plus 4. And then it's going to be x minus 0 because, or x plus 0. It really doesn't matter because my x-intercept here was 0. So again, sorry about that. Everything that I just wrote, make sure you write it down for part C. And I'm going to be checking for part B and D whenever I see you in class next time, okay? So that's going to be it for today. I'm sorry I'm making you guys watch all these videos at home. I know you guys just want to relax, but we have to do what has to be done, right? So yeah, hopefully this will get us caught up and we'll do good on the exam next week. Y'all have any questions, please let me know. Hopefully y'all have a great Monday, and I'll see you guys on Tuesday or Wednesday. Bye.